X-ray diffraction, like any other analytical technique, requires good data to perform a good analysis. In this video, we will show how to evaluate your powder diffraction data quality and adjust scan parameters to obtain the best data possible. We illustrate this in Data Collector, but the same principles can be applied to any system and software. Most XRD scans require specification of the angular range, step size, and time per step as part of the scan parameters. Let us examine this data collected from a powdered specimen for the purposes of phase identification. At a minimum, the 5 most intense peaks are needed to uniquely identify any phase. So, our scan range must be large enough to capture all these peaks. This depends on your sample type and X-ray tube, but some general recommendations can be made based on the sample type for a copper tube. For pharmaceutical compounds and clay minerals, 4 to 40 degrees. For inorganic mixtures, 10 to 70 degrees. And for metals, 30 to 130 degrees. In our example, we can see 12 to 15 peaks, which is acceptable. It is good practice when designing a new method to begin with a quick scan as shown. This allows us to evaluate and adjust the scan parameters before committing to a longer scan. Next, click and drag to zoom into one of the low-angle peaks. Right-click on the results window and select Peak Mode. The parameters of the most intense peak in the zoomed range are shown. The optimal step size for a scan is 1/10 the full width at half maximum of the narrowest peak. In our example, 0.02 degrees is suitable. Using a smaller step size does not increase the resolution of the scan. This is a property inherent to the hardware of your system and sample preparation. Too small of a step will oversample your peak, revealing no additional information and extending your measurement time. Conversely, if the step size is too large, your peaks will be undersampled, leading to inaccurate position, intensity, and width determination. Lastly, we examine peak intensity to determine the correct time per step. We recommend a minimum of 1,000 counts on the most intense peak of interest for phase identification, or 10,000 for read volt. In our example, we need approximately 5 times the counts, so we increase our time per step by a factor of 5, or repeat the scan 5 times. Having adjusted our scan parameters, we repeat the measurement to confirm the statistics are suitable for our analysis before finalizing these settings in an absolute scan program. These guidelines are very general to powder scans, but the same principles can be applied to any measurement. For example, if you are interested in a trace phase, the count times should apply to the peak you are using for analysis. Or, if you have strongly overlapping peaks, a smaller step size may improve results. This must also be balanced with your throughput needs. Using a larger step size or smaller range makes for a quicker measurement. You now know how to assess the data quality from an XRD scan and modify scan parameters for suitable data quality and throughput needs. For more information, please consult our other support videos or contact your local organization using the information in the description below. Thank you for your attention and for choosing Malvern Panalytical.